mulesoft developer practical and conceptual questionnaire, and these are the most important things uh, in the mulesoft developer lead position they are asking. So this is the array of JSON elements, and they want the output like this. So this one I have created a separate video. You can go to see that video, and also for this one also I have separate video I have did. So yeah, we'll go this one, wheels of conceptual and architectural questions. Application architecture. Can you explain the high level architecture of the application you have worked on? So for this one, the answer is based on mulesoft best practice. High level application architecture typically follows the API led connectivity approach, creating a network of reusable APIs. An enterprise integration solution is segmented into three distinct layers of APIs: system, process, and experience. So anypoint platform. So entire architecture is built and managed within the anypoint platform, which serves as a central hub for the complete API lifecycle. Includes design center. We have anypoint exchange. So design center, yeah, will web-based environment for designing and building APIs and integration flows. And anypoint exchange, marketplace for sharing, storing, and discovering reusable assets such as templates, connectors, and APIs. API manager, control location for secure and governing APIs by applying policies, security, throttling, and other controls. Runtime manager used to deploy and manage mule applications in various environments, including cloud hub, runtime fabric, and on-premises. API led connectivity layers. So this is the we have three layers, right? So the purpose is to provide the data in format and structure needed by the front-end user interface. This decouples the client from the underlying complexity of the back-end systems. So we have system API. So purpose to abstract away the system level details and focus on reusable business processes. This enables agility, and as basic logic can be changed without impacting the underlying systems or the experience APIs. So example also we have given, so we can go through that. Next we have see here the mule applications for each API are executed by the mule runtime engine, a lightweight Java based runtime that effectively handles message routing, transformation, and processing logic. Depending on the development model, the runtime can be hosted in different environments. Cloud hub, we have runtime and hybrid on premises. Cloud hub, so it's a mulesoft managed by integration platform as a service, iPaaS, which provides an elastic, secure, and highly available cloud environment for deploying and run mule application. Runtime fabric, this is a different one, containerized development option that allows for the orchestration of mule runtimes on a private cloud, AWS or Azure. So this offers greater control over the runtime environment while still managing it from the anypoint platform. So for organizations with specific security or compliance needs, the runtime can be installed and managed on premises. So if some client want to have security, so that they will keep runtimes in their on premises, and they will monitor. Application flow overview. So a mobile application makes a request to Experience API. Experience API receives the request, processes the input, and calls the appropriate process API, fulfill the business logic. Process API orchestrates one or more calls to the relevant system APIs to fetch or update data from the backend system. System APIs interact with the core systems like Salesforce database, SAP, other ETL, CRM related. Data is transformed between system at every layer using data. This response is sent back through the layers, which each API formatting the data for the next layer in the sequence. Finally, the experience API returns the formatted data to the mobile applications. Okay. So API led connectivity. So handling failures. How we handle failures. So if a downstream system fails, database, Salesforce, SAP, how does it impact overall architecture? So failure in a downstream system integrated with mulesoft can significantly impact overall architecture, with the extent of the impact depending on the integration design and error handling strategies implemented. So potential impacts: service disruption, and data inconsistency, cascading failures, performance degradation, user experience impact, resource exhaustion. So these are all the impact. This will be impacted. Something is fail, something is so migration strategies to mulesoft in mulesoft. So what we have to do: robust error handling, implementing comprehensive error handling in mule flows using try catch blocks on error container error propagate to gracefully manage exceptions and prevent cascading failures. Next one is retry mechanism, configure intelligent retry policies with back of strategies to attempt reconnection to the downstream system without overloading it during recovery. So next one is circuit breaker pattern. Implement circuit breakers to automatically stop sending requests to a failing system for a defined period, allowing it time to recover and preventing resource exhaustion. So we can instead of calling multiple times, we can have a circuit breaker separate flow, and so that we can once it is up and running, so that we can call asynchronous process and queues. Okay, instead of waiting for the response from the target system, so we can use asynchronous processing, or we can go for queues to persist the data. Utilize message queues, ActiveMQ JMS, to decouple systems. If a downstream system is unavailable, message can be queued and processed once the system is recovers, ensuring eventual consistency and preventing data loss. Okay, then we have dead letter queues, so that we can send the capture messages that cannot be processed successfully after multiple retries, allowing for manual inception and reprocessing. So monitoring and alerting, implement robust monitoring and alerting to quickly detect downstream system failures, enabling prompt intervention and minimizing downtime. Idempotency, design integrations to idempotent where possible, allowing safe reprocessing of message without unintended side effects if a failure occurs during processing. So only idempotency means we can process only one time. So team integration, so when you develop an API, how do you ensure it integrates smoothly with components built by other developers? API-led connectivity architecture is there under design. So here we have Swick driven development. So we'll use RAML and Open API to design the our we'll define resources, methods, request response structures, and error handling. The comprehensive documentation, API specification documentation, external documentation. So like a separate portal covering use cases, authentication mechanism, error codes, and best practice for consumption. So consistency and standards. So consistent naming conventions, resources, parameters, and fields across the API. Standard error handling, implement consistent and well documented error handling mechanism, providing clear error codes and messages. Semantic versioning, version 1, version 2 for APIs to clearly communicate breaking changes and allow consumers to manage updates. Usability and modularity. So fragments and reusable assets in API fragments in API design to promote reusability of common components, data types, security schemas across multiple APIs. Shared libraries and connectors. Develop and publish reusable mulesoft connectors, libraries to endpoint exchange for common integration patterns or third-party system interactions. Testing and feedback, mocking and early testing, collaborative testing, governance, security, API governance policies. Implement API governance policies in endpoint platform to enforce standards, security, and performance requirements. Then security best practices, ensure the API adheres to security best practices including authentication, authorization, and data encryption. Roles in a mule project. What roles do architects, testers, and DevOps engineers play in MuleSoft projects? So in MuleSoft project, I will design the overall integration strategy. Testers ensure the functionality and performance of API, and DevOps engineers automate and manage the continuous integration and develop deployment pipelines. The three roles collaborate to deliver high quality, scalable and reliable interaction solutions using the endpoint platform. Role of architecture. Architecture is responsible for a high level design and strategic planning of the mulesoft integration solution. This includes both the overall enterprise integration strategy and the specific API design. Integration strategy. Define an architecture-wide integration blueprint using mulesoft's API-led connectivity approach, which creates a layered network of reusable APIs. System and platform architecture. Design infrastructure for the anypoint platform. Determining deployment strategies, cloud hub, on-premises, runtime fabric, and ensuring the solution is scalable, secure, and performant. Then technical governance. Define and enforce standards for development, code reviews, and API design. This promotes consistency and reusability across project. Monitoring and security. Configure monitoring tools and establish security policies to govern the APIs. Governance and mentorship. Provide technical leadership and guidance to the development and DevOps teams. Role of testers. So they will test API testing, end-to-end testing, and test automation, performance and load testing, defect management. Then role of DevOps. So they will create CI/CD pipelines using Jenkins and infrastructure management. Mule applications often using infrastructure as code. Tools like Terraform, development and release, deployment and release, automate the process, and they will deploy to Cloud Hub or Runtime Fabric. They manage environment configurations and implement version control, monitoring and alert. Also, they will configure monitoring and logging tools to track the health and the performance and availability of mobile applications, including setup alerts for potential issues. Troubleshooting. Provide support for operational issues, performing root cause analysis for production errors. So these are all the main things I have highlighted. So then we have debugging and diagnosis. So we can go to the logs and we can get the details if it is a data issue or anything is failing in the connector level. So we'll based on the exception details we'll get to know. See, while going to the directly login into cloud and we can see the logs, or on premises application server we can log and we can see using Splunk. Also we can directly query and get the details. Testing and validation. In UAT and pre-prod we'll test everything, and then after user acceptance, so we'll go for next environments. Connectors and integration best practices. So connectors have you used? How many connectors we have used? So database, HTTP, Salesforce, SAP, Jira, and other cloud related and other ETL, ERP, CRM related. When would you choose a custom connector? So if we want to connect to any specific like any database which is not supporting from MuleSoft, so that we can use Java code, and so that we'll give the connector configuration, host and port credential details, so that using that Java code we'll have a custom connector created, and will accordingly will use this custom connector, not only for a database, other systems also we can have that configuration, and using some custom scripting we can go for that. All the best practice for integration design, reusability, error handling, performance. Reusability, APIs, RAML we are creating, right? APIs we can reuse, API led connectivity we can reuse. So error handling, we'll have try catch block, and flow level we can do the error handling, and global error handling also we can have, and performance. So there are multiple things we need to keep in mind, like use data wave to create multiple variables, and use of default functions, and use custom functions, and reuse across the data wave. And also performance related, use streaming mechanism when we are consuming millions of data, processing millions of data, batch processing, and also parallel processing, and provide the proper exception handling, and capture the exception details. And also for auditing purpose, we can save those exception details into database or other external systems. And also apart from that, batch processing, parallel processing, and instead of logging complete payload, yeah, whatever required, yeah, we'll log those details. So yeah, these are all the best practices, and yeah, go through this video couple of times so that you will get to know. Thank you.